The last few things I want to talk about in terms of Chapter 8 are these last concepts about forming ions and some information about these magnetic properties. And so when it comes to forming ions, first thing you have to remember, and again I've told you this many times throughout the semester so far, you cannot change the number of protons for an element. So the only thing you can do in order to create an ion is to change the number of electrons. And so far up until this point, everything I've been talking about in the previous videos has had to do with filling in these electrons, giving more electrons to the atom. And so when you fill in these electrons, you have to follow the energy diagram I talked about at the very beginning, in which case you have to fill in your lowest energy orbitals first before you start moving up. Or basically, you have to start off at 1s2, then you go to the 2s2. But remember, things can get a little bit goofy because normally your brain and all human beings think 1, 2, 3, 4, 5 makes logical sense. But whenever you start filling in these electrons, because the s orbitals and those d orbitals do the weird little thing, you have to remember that you have to actually fill in your 3s orbitals, your 4s orbitals before you can fill in your 3d. And so that's all I mean whenever I say it can get a little goofy. Please refer to my previous videos and the notes and everything else about that whole idea. Whereas removing electrons actually makes some kind of common sense. Because when you remove electrons, you remove them from the highest energy level first before you move on to the lower levels. And what I mean by that is you remove everything from your n equals 6 before you even touch your n equals 5. You have to make sure every electron is out of your n equals 5 before you even start thinking about your n equals 4. And so, for example, if you look at indium here, we have the electronic configuration of krypton with 5s2, 4d10, 5p1. And so even though when filling these electrons up, we filled in the 5s, then the 4d, then the 5p, filling in order, as I've mentioned several times, is goofy. It's all weird. But whenever you remove electrons, you remove them logically as your human brain wants to tell you to do so. And so for this, if we want to make an indium 3 plus ion, we know that we need to remove 3 electrons. And so in order to remove these 3 electrons, you do not remove them in the same order in which you filled them up. You remove them by the highest energy level first, then you move in. And so for this one, the highest energy level is going to be my n equals 5. And so in n equals 5, I have my 5s2, 5p1, meaning the fact that n equals 5 has 3 electrons in it. And so if we want to make an indium with 3 plus, we're going to remove both of these electrons out of both of these 5s and 5p, and we end up with krypton 4d10. And so when you kind of go through and look at these, some possibilities are, or I guess it is going to be possible sometimes for you to have something like this 4d10. And so one thing you should notice is that the only time you can have that is if you've already for some reason taken electrons out of the ns before you've actually gotten to that 4d. And so the last little bit here when it comes to forming ions you should always keep in the back of your mind is cations, or positively charged ions, are always going to be smaller than their parent atom. And the reason for that is, remember, cations exist whenever you remove electrons from the atom. And so if you're removing electrons from a many electron system, you are decreasing the electron-electron repulsion. And because of that, your atom is going to start becoming a little bit more condensed because these repulsion factors are not going to be strong enough to basically overcome these attraction factors between these protons and these electrons. Additionally, whenever you remove electrons, if you happen to remove enough electrons, as I did in my previous example with the indium, I basically destroyed that entire n equals 5. And because of that, your atom is going to be slightly smaller because it doesn't have that extra layer on the outside. Anions, on the other hand, are going to always be larger than their parent atoms. And so here again, anions exist when you add electrons. If you add electrons, you're increasing the electron-electron repulsion, and therefore you're going to start having a little bit more repulsions rather than attractions. And the final concept I want to cover for this chapter has to do with magnetic properties. And so the magnetic properties are essentially, is this metal or this substance going to be attracted to a magnetic field, or is it just going to completely ignore anything that's even around it? You are all familiar with this concept. If you've ever had a magnet, if you stick it to a refrigerator, it will stick. It will become magnetically attracted. Although if you take that same magnet and you try to stick it to an aluminum can, you notice nothing happens. And so both of these are still metals. It's just the way that their electrons are lined up is what gives us the magnetic properties or not. And so the first kind of magnetic property is paramagnetism. And so paramagnetism means the fact it is attracted to a magnetic field. And the only time this happens is if you have even just one unpaired electron. And what I mean by unpaired is whenever you're filling in those energy like diagrams and you're putting all your up arrows and your down arrows, if there's even one orbital or one of those boxes or one of those lines that does not have an up arrow with a down arrow, this is going to be referred to as paramagnetic. And so paramagnetic, again, always exists when you even have just one unpaired electron. An example of this is gold. And so in gold, remember, gold is one of those funky ones that has a half orbital and a completely filled orbital. But gold is xenon 6s1 5d10. And because this is 6s1, it has one electron in that s orbital. Your 5d10 completely filled up. All those electrons have an up arrow with their down arrow. But in that 6s orbital, you only have one electron. You only have an up arrow with no partner. You have no down arrow to go along with it. And because of that, whenever this substance or whenever gold is placed into a magnetic field, that one electron that's unpaired can actually line itself up with the magnetic field and become attracted. Whereas on the other end of these things, you have these diamagnetic attractions. So non-attractions. And so the diamagnetism is whenever you have your substance that is not attracted to a magnetic field. The reason for this is every single one of those electrons is paired up. And so example, mercury. Mercury is not attracted to a magnetic field because it has 6s2 5d10. 6s2, there's 2 electrons in the s orbital completely filled up, meaning that each one of those electrons is going to have a partner. 5d10, again, every single one of those up arrows has a down arrow. So as soon as this substance is put into a magnetic field or anything, all those arrows or all those electrons are basically ignoring the magnetic field because they already have their partner. They don't want to flip around. They don't want to switch. They don't want to do anything. And so remember, magnetic properties are always going to have some type of influence. Sorry, other way around. Electrons are always going to have some influence on how these things are going to be attracted to a magnetic field. Hope that sums everything up for Chapter 8 for you.